Hello, my name is Nuan, and this is a small introduction to data communication under the wireless network technology. So, this is the overview of what I'm going to explain. So, basically, what is data communication and standard and forums, and data communication model, main components in digital communication. So, each component of that communication in kind of a deep introduction, and the multiple access methods. So basically, what is data communication? So data communication, so we can have to have a sender, and we can have to have a receiver, and we have to have a medium. So sender is sending information into a large distance, it might be. So in the transmission, it can be happened as simplex. That means it is one-way transmission. The only sender can transmit information to the receiver. Either way cannot. So the good example is the television. So we receive the signal, so we cannot sending signals by using the television. And the half duplex. That means the both parties can participate to the communication, but not at the same time. They have to wait one end until end in the transmission. And the example of is a walkie-talkie. So one end have to be end, and then other can participate the communication. And the next level is the duplex. Duplex means sender and receiver can both participate to the communication at the same time. So the mobile communication. So standards and forums. Why the standards and forums are here? So why they are? What are the functionalities of them? So they are the people who are researching the things, and who are amending, revising, and promulgating, coordinating, developing of the technologies or standards of the technologies. If the technology is out there, so they have to have a standard, because it is using worldwide. So in a person in China and person in United States, both have to have implementing, let's say, two equipments using some kind of a protocol. So they have to have maintain the same standard. Otherwise, the development of one party cannot be used by the other party. So that is main idea about the behind that. So there are some various other standard bodies which are not emphasizing here. So there are some various kind of like electrical and IT and various kind of. So then here an example of Institute of Electrical and Electronic Engineers. So they are developing some protocol standards like Wi-Fi, Zigbee and Mesh. They are famous 802 standards. And then the forums. So they are also participating to that, evaluating and standardizing new technologies. They are conclude like universities. So they are conclusion to the standard bodies. Okay. So they are make strong around the standard bodies and make strong them. That is the difference. So the data communication model. So why we are using this model is explaining the data communication. That is why we are using a model. So this is a layered model. That means there is a stack. The stack is traversing bottom to top or top to bottom. If a sender is sending data, it is describing top to bottom, and the receiver bottom to top. And each layer have its separate functionalities and protocol set. So that's why explaining here. For an example, let's say the logical address. The address methods are there. So logical address, physical address, and port address. So physical and data link layer is using physical address, and network layer is using logical address. Physical address means the MAC address, and network layer is using the port logical address, and transport layer is using the port address. So there are some various kind of protocols also here. So that's why these images are here to describing how the communication happen. In physically there are no stack like this. Actually, this is kind of a model. So here the main components in digital signal transmission. So there are 5 components altogether. So in forward, I am describing all my presentation based on this model, these 5 components. If we can express these 5 components, then it is the data communication, right? So the sender is the sending. It can be a handset, telephone, workstation, anything, and receiver is receiving it. It can be same or different, and the medium of the transmission. So it can be wireless or wired. And then the message. The message is the information of the data that to be communicated, right? That can be numbers, images, video, audio, anything. So then the protocol. The protocol is the important thing. So without a protocol, so can you communicate it? You cannot communicate, because that is the rules and regulations govern to the both parties. So one can understand the other. So the protocol should be there, otherwise you cannot communicate. So let's moving in. So these are the things that I am going to explain. So what is the protocol and the difference between data and signal? That means the signaling part and the transmission media, I mean the medium part. So let's moving into the protocol. The protocol, as I explained, the set of rules so govern the data communication. So the protocol should have syntax, semantic, and timing. That are the properties of a protocol. The syntax is the structure or the format of the protocol. That means how the protocol is structured. So segmenting the bit pattern, that the frame and separate segment have separate structure, naming. So first one, address of the sender. So second 8 bit is the address of the receiver and the message. So this is simple format, but in the real world it is very complex than this. The semantic is the, as the name, the semantic. What is the semantic? With the meaning. And what is going to interpret of that segmented syntax. Example is here. So address identify the route to be taken or the final destination of the message. So that is the semantic. And then the timing. The timing have 2 characteristics, very important. The how fast and what data, when the data should be sent. So finally the expectation is sending right information to the right destination at the right time. Otherwise it will not be efficient. So example is here. So if a sender receiving 100 megabit per second and receiver receiving it 1 megabit per second, so it is not balanced. So you have to balance the sender and receiver. Load balancing is there, should be there. So otherwise the lot of data will be lost. So that is the idea behind that. Then let's talk about the protocols categorization. So there are various kind of categorization. So this is my categorization. The layered perspective categorization, like the OSI said. The domain perspective, that means how the domain of the protocol, that means is it a static protocol or is it a dynamic protocol? Those are describing routing. Then the functional perspective. So what are the protocols? So they are categorizing based on their functions. So let's say we have to transfer a mail. So we can use simple mail transfer protocol. Likewise. So media access control, CSMA CD, CSMA CA, TDMA, FDMA, OFDM, like that. Then moving into the signal part, very interesting part. That is, as the right side figure, so you can see that message. We are going to talking about the message. So before talking about the message, so we have to think about the data. What is the difference between data and a signal? So data is a kind of information, raw information or uncompressed information inside the location. That means it may be in your hard disk, it may be in a cloud, doesn't matter. It is an uncompressed raw data information. So signal means the transformation of that data. So we have to have transform data to signal to transmit, one sender to receiver. That is the theory. So in data it can be analog and digital. Signal it can be analog and digital. So analog signals can be periodic and non-periodic. Periodic means it continuous with the time. So periodic signal can be simple. Think about a simple sinusoidal wave. Composed means convergence of more than one signal. It will be a little bit complex than the simple sinusoidal. So there are so many components, signal components are there. So there are some theories to describe that, Laplace and Fourier. So let's talk about them in future. So digital also same as analog, so periodic and non-periodic. Okay, but the difference is digital is talking about two states, 0 and 1. That is the difference. Then the properties of a signal. So what is the important of this is to describe about a signal. To understand about a signal, we have to have and identify properties of that signal. That is why we learn about these properties. So peak amplitude, as you can see, there is an equilibrium margin level. That means the time here, time domain. So time equilibrium to the crest or the peak and or to trough or valley is called peak amplitude. The maximum excursion or deviation, as I mentioned in the slide. So what is the important is higher peak means the higher energy. That is the reason behind that. Then the period. What is the period? Period is very relative to the frequency. There is a inversely relational to the frequency. The period is the time taken to propagate one cycle of a wave. That is called by period. It is measured by seconds. So let's move into frequency. Frequency, as you already heard about that, frequency is 1 second time, how many cycles occurring or propagate. That is called frequency. The higher frequency is we using carrier signals in modulation. We can explain that higher frequencies are using because they have lot of energies. And other thing is the antenna theory. Let's say higher frequencies have small antenna we can use to receive, but lower frequencies we should have used large antennas. That is one advantage and disadvantage. So frequencies measuring using hertz. So wavelength, the other part. So wavelength is the distance between successive crest of valleys. So that is denoted by lambda. So it is also used to describe about the signals. So then let's move into time domain and frequency domain. So time domain and frequency domain are representation approaches, let's say. So it's basically as you can see, time is the x-axis, that means the dependent axis, and y is the independent. So it is sometimes called time series forecasting. Let's say in data science there are time series problems like stock market analyzing. So the other thing is biomedical engineering. The CTG scan is also example of time series. So those are time domain implementation. So we can apply theories of that. So time domain, the correlation is time and the amplitude. The advantage is, so we can analyze the behavior of the signal. We can see how the peaks are going and those things. For an example, CTG scan analyzing by obstetricians to predict the fetal status, the uterine contraction of a pregnant mother. So that is basically doing by obstetrician by analyzing that signal, the analog signal. So what are the other advantages? So scope measurement, that means how the pulses can be obtained by the observations. We can extract information using those things. So then let's move into frequency domain. So frequency domain, as you can see, it is very clear, right? Very clear. So the complexity of denoting signals, very clear. So we call it components. We can say 3f, 5f, like that, components. There's a base frequency component, then there are some other frequency components. And the stability we can calculate it. And filtering we can think about a filtering, that means low pass, high pass, or band pass filtering. So but in frequency domain, the convolution of two signals is just a multiplication. So that is a mathematical thing. So as I described earlier, so how we convert time domain to frequency domain is using there are some theories, mathematical theories. One is a Fourier transformation. So there are some various kind of Fourier transformation theories, like fast Fourier transformation, like that. So we can transform time domain to frequency domain, and backward also can. Frequency domain to time domain, that is backward Fourier transformation. And other theory is Laplace theory. So Laplace theory, using Laplace theory, we can calculate the stability of a signal. So that are the mathematical backgrounds. Then let's move into the bandwidth. So bandwidth is a difference or a variation of a signal. Equation, as you can see, the maximum frequency and the lowest frequency, difference between those two components. So it basically tells the maximum data transfer rate of a network. Okay, so how much the data can be sent over a specific connection. So then after that we can identify what is the maximum frequency. So in signal it is varying, so we can take the mean frequency and identify what are the how the frequency is changing around the centralized frequency, mean frequency, how the channel is changing. Those are mathematical parts. Okay, so basically we have to think about here, the larger bandwidth is more widely, there are more wide space to transfer in signal. Think about as a road. So wider road can transport or use by larger vehicles, not larger, many vehicles. Think about that. If the road is very narrow, the vehicles cannot move freely. Think about that. Then the modulation, very interesting part. So sometimes we have to have transform. The pulse code modulation is a digital, the signal transformation, analog to digital signal transformation. So sometimes the practical usage I have to explain here to get an idea, you guys. let's say we have a sensor. So we received analog signal of that sensor. So let's say a gas sensor. So the gas is the information is received by the sensor as analog. So we have to pass that analog signal to a processing unit, let's say a Raspberry Pi board. So that Raspberry Pi board is cannot understand analog signals, so it should be digital. So how we transform that analog signal to digital, that part is doing by this. So there are some modules or ICs, let's say, that we can transform that analog to digital transformation, A to ADC, we simply call ADC. So this is using that. So there are some lot of components, as you can see in a diagram. For nutshell, so I can explain it like sampler. So we have to sampling it. As you can see, it's a Cartesian coordinate. The vertical lines is called samplers. So sampling rate, higher sampling rate is very accurately we can reconstruction the signal. And then quantizing means the horizontal, we have to divide it. How many channels? Let's say 2048 channels. Then we can identify how many bits that we want to transmit that. There is a quantizer. So larger the quantizer it is. And then encoder and decoder, and we can finally reconstruction the signal. So that's how the pulse code modulation in nutshell. Okay, I think you have to have you got a general idea about that. Then the modulation. The modulation is used to transmit data, one to send, let's say transmit to receiver. So let's think about a piece of paper, we throw it, but it unable to reach the destination because of the air or because of anything. It's likewise signal is also, attenuations are there. Okay, noise, attenuation, basically the attenuation. So if we use a stone wrapped to that paper, then we can throw it far away. So same theory is applying here. Digital modulation and analog. Digital modulation is used for digital signals, analog modulation is used for analog signal. So ASK, FSK, PSK, let's talk about these things. So as name suggesting, so amplitude shift keying. So you can see in the middle there's a carrier wave, high frequency. So that is, we are trying to mix that carrier with the data signal. The data signal is digital in here, ASK. Amplitude shift keying, that means changing the amplitude of the data signal. Changing the amplitude of the carrier signal, not the data signal. So as you can see in the output or the modulated signal, the amplitude change, frequency is stable. Same frequency as carrier, but amplitude changed based on the data signal. That is how it explained. And the frequency, same theory. Then frequency change of the carrier signal, not the amplitude constantly stable, and frequency changed according to the carrier signal according to the data signal. And then the PSK, phase shift keying, that means phase is going to shift. This is also abbreviated as saying as BPSK sometimes. So here, as you can see, there is a carrier signal which is not depicted here, but think about there is a carrier signal in the middle. So that carrier signal, as you can see, frequency not change, amplitude not change, only thing the change is phase. the phase, signal phase. In phase and out phase, there are signal phasing, a property of a signal also. The phase is actually used for mobile communication, so it is for improving. It can be improving the amplitude, we can, or decreasing the amplitude also. So that means in phase and out phase, both, if two waves are in 180 different phases, then the summation of that, the convergent phase, is null. Think about that. Think about like this, it is like -5 and +5. So we added it, then it will be 0, like that. That's the concept. So here the phase is changing, as you can see. 0 to 1, change in the phase. 1 to 0, again change in the phase. And let's move into the analog signal. Same theory. The only difference is the data signal is analog. Other thing is same as digital. Here the same frequency. Only change in the frequency of the carrier signal. Then the multiplexing. Very interesting topic. The multiplexing means sharing. That means combining multiple signals into one signal and sending. And then demultiplexing. That means dividing those converged signal and separating it. So that's how communication happen in computers. Let's say there are mux and demuxes. In the tree diagram, as you can see, multiplexers can be analog and digital, and FDM, TDM, like that. There are words. Let's talk about those things. So let's move. So time division multiplexing. You can get an idea from the name, time division. So this is, let's say, the left hand squares, as you can see. The squares denoted by let's say 3 users, and A, B, C is data. So time division means the time means the sharing parameter. Equal time. Each user have equal time to share the information. If some user have a lot of data, but he cannot transmit more data, he have to use that time to transmit. So that is the disadvantage here. So to overcome that, this came statistical time division multiplexing. That means before arranging the times, they are analyzing the data set, the data information to be passed, and according to that they are slotting the time. That means the larger volume data have lot of time slot. So likewise it is optimizing. Okay, the extended version of time division multiplexing. Here the frequency division multiplexing. I have to say one thing here. Sorry. Time division multiplexing is used for baseband transmission. Baseband transmission means a one-way transmission. The medium is used for one way of transmission data. Let's move into the frequency division. So frequency division, as you can see, ABC signals transmitting over the medium, but they are not overlapping. They are non-overlapping. There are separate frequency bands for each one and transmit, and then demuxing at the receiver end. So this kind of technology is used for broadband transmission. That means in 4G, 5G, 3G, they are using it. So the theory is how they are non-overlapping. So it doing based on the guard band. So they are using a guard band to separate each channel. So let's move into here then. The OFDM, orthogonal frequency division multiplexing. What is the mean by orthogonal here? Orthogonal means two or more signals transmitting non-overlapping. But the difference is here, this is the extension version of FDM, that is right. But as you can see, they are not using a guard band. They are just overlap, but nothing happened. Because of why? Because of, think about the blue wave in middle. There is an intersection point in with the x-axis, as you can see. So if we draw a vertical line over that, so you can see that peak of that blue line, the peak of that blue wave. The intersection point, the other two waves, pink and yellow, is null with the energy. When you think about the pink one, other two are null of the energy. So that's how, if we consider a one signal, others are not even. I mean, not even means they are out of, they are not in the picture even. So that's how they are transmitting. They are using the OFDM technology without using the guard band. That is the secret here. So satellite communication use this. Okay. So then let's move into the spread spectrum. So what is that spread spectrum means? So before that we have to identify what is the fixed communication. So as you can see in the right side, the diagram, 2.4 gigahertz to 2.4835 gigahertz. So fixed band is there, then transmit information. As you can see, the data is transmission horizontally. So this is just for presentating. Okay. In real world, these are not like this. This is a kind of model to present it. So the data, so anyone can get this data. Like, so in this kind of fixed communication, there are three kind of problems. Actually, it is slow down the transmission. What are those? Those are interference. There are some external interference to the information, and jamming, and interception. That means the security problem. So there are many modulation techniques to overcome those issues, right? So one is this spread spectrum theory. That means the narrow band signal are intentionally, that means biforcely, spread over a much wider band. So that is the theory. So there are two kind of spread spectrum that is here discussed: DSSS, direct sequence spectrum, and FHSS, frequency hop spread spectrum. First we talk about frequency hopping spread spectrum. So as name denoted, so hopping. So as you can see that x-axis, so this channel is divided into time, slots and frequency. So there are some Cartesian pattern. So what happened is the data is passing into F2 channel, but it is not continuously transmitting. It is jumping like a monkey, hopping. So you can see hopping time here. So jumping like a monkey, and it called hopping pattern. So hopping pattern is only knowing by the receiver and sender. No anyone can knowing it. So different senders can use different hopping patterns at different times. So that's why these technology is used in military application, because of the high interception, the high security. And GPS also use this. That is basically the FHSS means. Then the DSSS, direct sequence spectrum, as you can see, so it is, theory is different. So data is there. So what you are doing is, it is combining, the data is combining directly with the higher bit rate, but it is noisy. We called it pseudo noise sequence. So we mix that signal with the pseudo noise sequence and transmit it. So that's why this method is also used in wireless communication. Then let's talk about the medium. In what is attenuation, distortion and noise. Okay, so I will describe about this. So attenuation is called a loss of energy, losing the energy in transmission. So we are using amplifiers to gain that energy. And distortion also. So distortion, change in the pattern. So that may be change the bit pattern. And the noise, most famous one. So there are a lot of noises cause to reduce the energy. So that is thermal noise, because of that electron traversing, because of, and crosstalk, impulse noise, induction. So those kind of noises are there. And the type of transmission media, again, the wireless. So let's talk about those things, and then the error control. So transmission media, so can be basically wired and wireless, right? So in wired, it can be further divided into twisted pair cables and fiber optics. In twisted pair cables, again can be divided unshielded and shielded. The advantage is shielded is protected, because there can be adding noises because of that lightning and those things. So it can be prevented using these kind of things. And the fiber optics. Fiber optics is also here. Single mode fiber and multi-mode fiber. So the theory is the reflection of the light. Optical fiber. That's why we call optical fiber. The construction of the fiber is core, cladding and buffer coating. So those are helpful to reflect the light like this, right? And the other things, the wireless thing, the radio waves. Basically we have to get an idea about that there is a electromagnetic spectrum. So there are some various frequency ranges in there. So that's why we use separate radio waves, types of waves. And that's why the bat here more than us, the frequency range is different, and dogs and some animals, right? That is the reason. So they can hear different kind of spectrum range. Then the error control. So what is an error means? So send and receiver. So sending information is not coming into the receiving. So there is kind of error. No. So error means so transmission is happening ones and zeros. So the error means then changing ones or zeros. So it can be one bit changing. We call it single bit error. So it may be multiple bit changing. We call it multiple bit type of bit error. It can be divided like multiple bit errors. That means randomly more than one bit changed. But burst error means the consecutive bits, the adjacent bits are more than one bit. So there are some error control techniques to identify that, because we have to first detect the error and then we have to correct. So for detect the errors, we can use this kind of techniques, parity check, which is useful for checking one bit change, and checksum and cyclic redundancy check. Let's talk about those things. The parity check. So parity check is checking one bit type of error. The theory is we adding one extra bit in the sending end to the data, and in the receiving end we can think about how it changes. So here it is two kind of even parity and odd parity. So we add a one bit, then it is even because there are 4 ones. So at the destination, then if one bit change, then it will be odd. Then we can think about there is error. If 2 bits change, then again what happened? There is no error, but it is an error. So that's why the parity check is not good for burst errors or multiple errors. So for that there is a checksum and cyclic redundancy, we call it CRC. So checksum here segmenting the original data and then adding it and using ones complement and get the checksum, and then at the receiver end using that checksum and add the received information and then get the ones complement. If the complement is 0, then error free, otherwise there will be an error. So we have to use error correction technique that we are going to discuss later. And the cyclic redundancy also, the sender is using a divisor, we called it pseudocode as I remembered, and the bit pattern or the sending data divided using that, and we get the CRC. Then CRC is added to the receiver end and then divided into same divisor, and then if it gets 0, then no error. So very simple theories to describe about error detection. And then error correction. There are some lot of error correction codes. Line code is one thing. Okay, it is not describing in here. So line code is one way to error detection and correction. And also it is using clock recovery. So this Hamming code's binary convolution code, read and low density parity check code is used for error detection, error correction actually. And that's how it's ending. But I have missed one part, I think, that is the multiple access methods. So there are some techniques, I'm explaining it without slides. I'm very sorry about that. So one thing is TDMA, CD, CSMA CD, CSMA CA, and FDMA. So frequency domain multiple access, time domain multiple access, and CSMA CD, carrier access multiple access with collision detection and collision avoidance. So those are basically used wireless communication. So it is called multiple access techniques. So there are some older methods like Aloha, slotted Aloha or PO Aloha. So those also are detecting there are medium to share. So more than one users are there, so they have to access the media. So at more than one users try to attach with the media or try to communication with the media, there can be collisions. So we have to avoid that collisions. So that's why those techniques were there. So they are using different time slots and different frequency ranges, different algorithms also there to control these techniques. So that's how the end of presentation. Let's ramp up for today, and you can follow me in Twitter or you can send me emails about my presentation. So have a nice day and thank you very much for listening to my presentation.